Hey guys, welcome to my basement and our first of, that's yet to be seen, how many of these online lectures that we're going to be providing and you're going to be working through. I hope you guys are safe and taking some time to spend with family and loved ones and maybe catch up on some things that you have been neglecting for maybe some period of time. And so just before spring break, we were talking about groundwater and groundwater surface water exchange. And we're going to jump back into that material. But before we do so, I want to, we're going to sort of skip ahead to where we were working last, which is going to be way down here, where we were talking about groundwater inputs. All right, so we're going to start right here. And you'll recall that it is the flow of water through the hyporheic zone that really promotes biogeochemical processes. And so a lot of those biogeochemical processes, happen in the hyporheic zone, which is that area at the base of the stream. And it's sort of an area where there's lots of microbial interaction. There's a lot of surface area for microbes to adhere to. There's a lot of gas exchange and lots of good nutrient flux, et cetera, that happens in this hyporheic zone. So it's a really important area. And there's a lot of sort of new research that's taking place in this area as well. So remember that groundwater that seeps into the streams provides that base flow for a lot of perennial streams. And if that water table declines, then you can get a really disrupted base flow of these streams, and that can be due to evapotranspiration or groundwater pumping, for example. And the actual flow into the lakes is dependent on geologic and vegetative factors. So remember that the underlying geology is really what structures the near surface terrain, and therefore the strata that is really what's driving the shape and form of a lake or a wetland. Also, remember that vegetation during the summer can affect the direction of water movement. So you can imagine that in the summer when there is evapotranspiration occurring, and you can see the evapotranspiration occurring here, and so this reduces the water table in this area near trees. And so this really can impact nearby trees. So you can imagine if there are forbs or herbs or things like that growing underneath these trees, that they could be experiencing sort of drought conditions due to these larger trees if there's rapid evapotranspiration. And then, so in this situation, water can be extracted from both lake and groundwater. So for example, here you can see this is surface water, and you can see that there's a chance of water being extracted through the ground due to through percolation and capillary forces that allows these trees and plants to take that up. And the difference between a wetland and a shallow lake is really primarily driven by their respective size. That's generally expressed as the both surface area and water depth. And coupled with the size are these functions that are collectively expressed by vegetation, associated sediments, and microbial activity. And so wetlands are areas that are inundated or saturated by surface water or groundwater at a frequency and duration that is sufficient to support, under normal circumstances, a prevalence of vegetation that is typically adapted to saturated soil conditions. So it's a sort of a long-winded definition, and really what that means is that there are these three characteristics that really drive what makes something a wetland, and they are hydrology, soils, and plants. And in terms of hydrology, this means that for there to be a wetland, it needs to be water that is near or at the surface of the land for some period of time. And with soils, the soils need to be hydric or saturated, and that really creates anaerobic conditions, so conditions that are void of oxygen. So there are the processes that happen in the soils that are hydric are anaerobic, and they're typically driven by microbial action. And then there are also plants that are associated with wetlands. So there can sort of wetland plants, and they require a lot of water, and they evolve to survive in these specifically hydric soils. This is sort of showing the classic wetland soil profile, and you can see that real sort of gray color. That's indicative of an anaerobic soil. So wetlands occur in many landforms and climates. They can be streamside or riverine. They create wet meadows, depressional wetlands, peatlands, playas, saltwater marshes, forested swamplands, and coastal mangrove forests. So in general, wetlands can be described as inland and coastal types. So in contrast to wetlands, riparian areas are the interface between the terrestrial system and the transitional zone to lake streams or wetlands. However, some riparian areas do include wetlands. So you can have an area that is a riparian area that is also a wetland, or you can have a wetland that is in a riparian area, but a wetland doesn't have to be a riparian area. And then coastal wetlands provide valuable food, spawning areas, and general habitat for fish that's been part of their or all of their lives in saltwater. So these areas are really important for a lot of fish species, particularly in the larval and juvenile stage, where they can escape predation. And these areas can also be affected by changes in discharge of sediment, or discharges and sediment and pollutants that are inputs from rivers in coastal areas. They can be either positively or negatively affected by upland watershed management. And this is just a box out of your textbook, sort of showing different types of wetlands, and I sort of spoke about those, but that sort of identifies each of those different types of wetlands. And so why are wetlands important? Other than ecological value, they provide ecosystem services in a really great way. And so ecosystem services, swamps, and floodplains are estimated at about $8,000 per acre. And so those ecosystem services of South Louisiana, and those include the Cypress Tupelo areas, and all of the Cypress Tupelo acres, that's equivalent of $6.7 billion worth of services. And then southeastern Louisiana, Cypress Tupelo timber, $3.3 billion worth of timber. And then in terms of freshwater fisheries and wildlife commodities in Louisiana in the year 2002 is estimated at $278 million. And then wildlife-associated recreational expenditures in the year 2001 was $1.2 billion. So there's a great economic value to wetlands, and particularly the ecosystem services part a lot of times is not accounted for when we think about wetlands. And wetlands have been declining for quite some time. Sort of the original, if you will, number of acres of wetlands in the United States was somewhere around just shy of 25 million. And you can see there's been a steady decline where today there's about 5 million acres of wetlands remaining. So that does it for this chapter, sort of short. And I think what I'm going to be doing from this point on is sort of breaking up the chapters or the lectures into maybe 10 to 20 minute sections, and you'll watch those sections, and then you have to maybe answer a question or two before you can move on to the next section. The questions that you answer will not be graded, but they will be required. So I hope this was okay for you. Please let me know if you have any questions. You can send me an email, or you can connect to me through Canvas, and we'll chat again soon.